My screen is visible, Nama?
Yes, ma'am.
Okay.
Yes, sir. Yes, madam. It is visible.
Okay. So indexed sequential, yesterday I explained about the indexed sequential. So indexed sequential means how we can access our data, how we can access our files. This means using the primary key, we can access easily. Okay, so this is also using the primary key only, but this is the advanced method for the indexed sequential method. Okay, so it will be looks like the tree structure. So diagram is available here. They see here like a root node, childs means parent node, children's, like that. It is a like in the form of the tree structure. Okay, so it uses the same concept of the key index where the primary key is used to. So means what here? So in the root node, in the tree structure also, we can use the primary key only to access the files. To access the files in the tree structure also, we are using the primary key only. Okay, and this B plus tree is also similar to same exactly binary search tree. So actually these are what binary search tree means. If you know C language, C with data structures will be there. So data structures mean data will be stored in the two types here: linear structure, non-linear structure. Again, non-linear means we are having there trees, graphs. These are the non-linear structure of data. So in that we are having the binary search tree. So that's why he is given here B plus tree is similar to the binary search tree. Okay, but binary search tree we are having two children only, but in that we are having more than two children. In the B plus tree we are having more than two children. Okay, and all the records are stored only at the leaf node. So at the leaf node, so see in the diagram how it will be stored here. So this is the root node. So this left side the root node, left side leaf node, and the right side leaf node, the children are there. So like again, if you want to store, again left side leaf node, right side leaf node. Again here left side, right side. If the children will be there, they can be, how they can be insert data, how they can be form the tree structures means left side, the right side, the leaf nodes they can take. Okay, and the leaf node is act as a pointer. So what is a pointer actually? A pointer is the address of the another variable. So it can be stores the address of the another variable is called as a pointer in the C programming. So that is the concept of the leaf node can be stores the records. So see here, first of all, root node, what is there? 25 is the root node here. So here is children's. What are the children's? It contains here 15 and 30. Okay, so the above P plus tree, see here in the point wise he explains, that only I am explaining here. So the above B plus tree shows that it is a B plus tree. So in that here the main root node is what is there? 25 is the root node. Okay, and there is an intermediary layer with nodes. Means actually every leaf node they are having the children's are there, and they are like working as the pointers only. Okay. So left root node contain the what the value it will be contains here. Like generally he says, compared to the left root node, left leaf node, this value will be higher. Okay, so 25 is the root node. So less than 25, whatever the values will be there, we can store left side, and right side, whatever the more than greater than 25 values will be there, we can store at the right side. That is explained. So that's why here 15, 30 are the children of the 25. Then we can store at the left side of the leaf node, and 30 is the higher than the greater than 25. That's we can store here the right side respectively. Okay, and again 15 here having the two nodes here. Okay, so left side the leaf node contains the three children. So in the B plus tree it contains more than two children. So in that at the end of the children contains the three nodes here. Okay, so what are the children? So 10, 12, 15. So 10, 12 are the lesser than the 15, and 15 also they can give in the left side of the leaf node only. So more than highest than the 15, right side of the leaf node, they are the values are the 17, 20, 24. Okay, so here the 30 is the root node for these children's. Okay, So the left side, the values will be like 20, 27, 29, 30. Okay, so that's why it will be stored say left side of the root node. Okay, so this is the way to create the B plus tree. So B plus tree contains the more than 2 children, and the children nodes we can store the leaf nodes at the left side leaf node and the right side the leaf node, and the less than values will be stored at the left side, and the right side we can store the highest values, greater than values, greater than the root node value. Okay, that is the concept. And what is telling? If you want to search for any record, then all leaf nodes will be balanced in this method. Then we can easily access the records, easily access the nodes. Whatever the node you want, we can easily access. If the B plus tree is the balanced tree. So balanced means what? Equal children will be there. Then that is easily we can access. So now see working with the B plus tree, how they can be working. So B plus tree is a balanced binary search tree. And directly he given here B plus tree is a balanced binary search tree, and it follows multi-level index format. Multi-level means what here? Root node, again subnodes, again subnodes, again subnodes. So the tree structure will be continued. So how many you want to be created here, you can create here. Okay, that's what it's called as a multi-level index format. Multi-level index format. And in B plus tree, leaf nodes denote actual data pointers. So pointers means what? Address of the another node. Address of the another node. Okay. And and what is giving here? Leaf nodes nodes remain the same height. Means here 25 having 2 children. Again 15 having 2 children. Equal. Same height. Same height children means the same children balance will be in the B plus tree, and we can access the any node randomly means what? If you want to 12th node, if you want to 30th node, so whatever the node you want to be, you can easily randomly access it using the B plus tree. So B plus tree concept completely based on the primary key only. In that he given internal nodes and leaf nodes. So what are the internal nodes here? Internal node of the B plus tree can contain at least n by 2 records of the root node. Means mainly here see in the diagram, this is the root node. So actually what n by 2 means? Minimum 2 children will be there here. And means minimum 2 children, half of the children will be there. That is the internal node. Okay. And leaf node means what? A leaf node of B plus tree contains same again he given that also contain the n by 2 record pointers only and n by 2 key values only. So at most a leaf node contains n record pointer and n key values. So see the here problem will be there, then you will be easily understand. So here the main root node we are having 25, 50, 75. This is the root node. Actually, what is the in the mainly we are root node what we are having? 3 values we are having 25, 50, 75. So less than 25 whatever will be there. So this leaf node we can store. And the 50 whatever the 50 less than values whatever will be there, we can store this side. So more than 25 if any values will be there in that, then here this side, but already we have the value here. So more than 25 means automatically less than 50 only. Okay. Again, here more than 50 means this side, less than 75 means this side. So like that, it can store the values here. So so more than 75 this side. So 25, 50. So here 20 below 25 what we are having 5, 10, 15, 20. Below 50 what we are having, or more than 25 what we are having 25, 30, 35, 40. These are the less than 50, okay? And less than 70, what we having 50, 55, 65, 70, okay? More than 75, 75, 80, 90, 95. These are the more than 75. So that's why we store at the right side, okay? At the leaf node. So if you want to insert one value Actually, what value he wants to be insert here? 60 value he wants to be insert. Okay. So according to the rule, where we have to insert at the third node. Okay. So third node between the 55 to 65. So between after 55, 60 will become before 65, 60. So between these two values, we have to insert the 60 value. So what he's done here actually, so if we can divide this node, then easily we can insert. So see here, suppose we want to insert a record 60 in the below structure, it will go to the third leaf node. So where is Goma? This is the third leaf node. After 55, so 60 will becomes where? After 55, 60 will becomes. It is a balanced tree. So B plus tree is a balanced. So all are the equal here. All nodes will be equally. We have to be maintained. The height of the tree is equally. We have to maintain. And the leaf node of this tree is already full. Already actually correct balance is there. So we can't insert the 60. So that purpose what he is doing here, the third leaf node has the third leaf node what values contains? 50, 55, 60, 65, 70. These values it contains. And its current root node is 50. So actually what is the current root node? It has a 50. So we will split the leaf node of the tree in the middle so that it is balanced. That its balance is not altered. So we can group 50, 55 and 60, 65, 70. Okay, what is the, if we can divide, it's not balanced. So that's why 50, 55, one group of the node, and 60, 65, 70, one group of the node. Okay, two leaf nodes we created in this. Okay, we are separated. So see here in the example. So what he has done here, so after 50, 55, one group, then after 60, 65, 70. Actually, before where it is, after 50 it is. Okay, now where he inserted, so here 60, he taken the root node, okay, and then 60, 65, 70. So this is the way to insert the value in the, so first of all, we have to check the value will be less than the root node or or greater than the root node. So like that we can insert the value. Okay. So this is the important question in examination point of view also. So you can write this example for an examination also. And how we can delete the B plus deletion. How we can delete the value. I mean value means node. So suppose we want to delete 60. So again in the above example he inserts 60 only. Here also he want to be remove the 60 only. So we have to remove 60 from the intermediate row node as well as from the fourth leaf node too. So where we have to remove here? This is the fourth leaf node. Okay, where is there 60? Where is the 1, 2, 3, 4? Okay, 1, 2, 3, 4. In the fourth leaf node, 60 is available. So if we can remove the intermediate node, then the tree will not satisfy the rule of B plus tree. So we need to modify it to be a balanced tree. So balancedly we have to remove. So like for this purpose, before whatever the structure will be there, that comes here. Okay. So before what is there, like 25, 50, 75. Okay. So that only comes here. So whenever we deleted that, then what happened? 20, 55, 75. So then 60 is easily removed. This is the process of the B plus tree file organization. So in this method, searching becomes very easy as all the records are stored only in the leaf nodes and sorted the sequential linked list. So in this, the nodes will be stored where the nodes will be stored at the leaf nodes, the nodes will be stored. And this also sequential order means in essential. Sequential means what? Ascending order, 5, 10, 15, 20, 25, 30, 35, 40. If you can observe here, ascending orderly, we are storing the values. Okay. So whenever we want to be insert, delete is also easily, and searching also very easily. Okay. Searching, if you are searching any node, that is also very easily. And traversing through the tree structure is also easier and faster. So wherever you want to insert, wherever you want to delete also, we can easier and fasterly use that. Okay, and the size of the B plus tree has no restrictions. Here no restrictions. That means how many children we want to give, we can give. So the number of records can increase or decrease. If you want to increase the records, if you want to decrease the record, there is no problem. And B plus tree structure can also grow or shrink. Means what? Increasing, decreasing. That only. Growing means increasing, shrinking means decreasing. And it is a balanced tree structure, and any insert, update, delete does not affect the performance of tree. So whenever if you are inserting, if you are deleting, there is no effect of the main root node. Nothing. Means the rule is rule. Rule we have to follow. Rule is what? Just less than values will be left side of the leaf node, and the greater than values will be right side of the leaf node. We have to be maintained. That is the mainly concept of the B plus tree. Okay. Next, the heap file already explained yesterday only. Heap file, how we can. So there is no order is not there. Unorderly we can store the files here. So in the diagram you can see order is not there. Okay, wherever the empty space will be the first of all 736, then 538, then 637, then 273. Okay, there is no ordered. So like way how the records are stored here, block 1, block 2, block 3. Okay. So here randomly we can access the data easily. Randomly, if you want to R1 will be this is, R3 will be like this. Which data you want to access here, easily we can access using the heap tree. Next, now see data dictionary. Okay, what is a data dictionary? So generally dictionary means what in English language? Dictionary means collection of the meanings, English vocabulary. Okay, we are searching. So any meaning if we doesn't know, we don't know, then what we can do, we can open the previous generation. Actually now we are having, everyone having the Google. So we are opening the Google, then we search the any information, any doubts, whatever we are having directly. But previously, if in English we want means everyone mentioned Oxford English Dictionary. So here also we are having a data dictionary. So data dictionary is also called as a data definition matrix. Okay, provides detailed information. So what it will be provides detailed information about the business data. So that means what again, such as standard definition of data elements, their meanings, and allowable values. Means whatever the business data will be there regarding of that, what are the data elements you are storing, and what is their meanings, and what are the values are there, like that complete information about the business data, it will be stored. So while a conceptual or logical ER entity relation diagram will focus on the high level business concepts. So we know conceptual or ER model. So how we can store data in there, like diagrammatically. Okay, entity, weak entity, strong entity, relationships, 1 to 1, 1 to many, many to 1. Okay, unary, binary, ternary. So using that diagrams, we can store the data. A data dictionary will provide more detail about each attribute of business concept. So data dictionary will be gives what means complete elaboration, explanation about the business data, business concept purposely. Means employee, for example, any company will be there, Flipkart company will be there. So what is the data dictionary will be stored means what are the products they used, what is the what about the products, the cost, quality, order, when they ordered, when they delivered. So everything will be there. Okay, so here Flipkart is a business data only now, maybe like employee data also, customer data also, again products, invoice numbers also, completely elaborately they can be stored internally. Okay, essentially a data dictionary provides a tool that enables you to communicate business stakeholder requirements in such a way that your technical team can more easily design a relational database or data structure to meet those requirements. Means it is one of the tool. Okay, data dictionary is one of the tool. So we can, whatever requirements we need, so if we can ask the stakeholder, they can be prepared for the relational database. Means table, in the table form, the data will be stored. So if data we are having complete details about our company, okay, regarding any products, employees, customers, whatever the transactions we performed, they all will be stored in the data dictionary. So it will be helps. What will happen? It helps avoid process mismatches, such as requiring information in a field that a business stakeholder can't reasonably expected to provide. So are expecting the wrong types of information in a field. So if we are having, if anyone giving the wrong information also, if we already having, we already saved our data, we already prepared our data in the data dictionary, so we can open that and we can use easily. Okay. And we will be happy to learn that they have an ideal home in a data dictionary. Means if the data dictionary is available, then we can easily access our data. Easily, whatever data we want, we can easily access it. And data dictionary provides information about each attribute, also referred to as fields of a data model. So attribute means what, ma? If we can take the employee data, employee table, employee number, employee name, salary, age, phone number, these all are the attributes. So it will be gives the complete details of the attributes also. So for example, if we were to create a data dictionary representing the articles here on bridging the gap. So we had potentially have attributes. So what attributes like article title. So this is one of the article book. Okay. So what we can create article title. What is the article we have? We are creating article author. Who is the article author? What is the article category and article content? What is the content will be there? These all are the attributes. What these are? Attributes. Attributes means nothing but columns of a table. So whenever we can, if we want to access data using the article title, if you are giving the primary key, so how many titles available in that database, particularly in that relational database, we can easily access using the primary key. Means these all are where it is available means in the data dictionary. What he's telling me. So a data dictionary is typically organized in a spreadsheet format. So spreadsheet means what? Tables, rows and columns format. Okay, spreadsheet means table format, data dictionary will be stored. And each attribute is listed as a row in the spreadsheet and each column labels as an element of information that is useful to know about attributes. So like, and also what is telling, storage is organized using various methods. So to store this data, so where we are storing the data internally in data dictionary. So the methods we are having, different methods we are having. What are the methods we are having? Indexing, hashing, B+tree, RAID. These all are the storage methods to store the data. In the data dictionary, you want to be stored. So data will be stored in the format. How the data will be stored means in the Excel format. Excel means what? Rows and columns. Spreadsheet means what? Excel. Spreadsheet is known now, you people. Spreadsheet means what? Excel, Microsoft Excel. Okay. So in the Excel, how the data will be stored in the form of the rows and columns. So to store the data in the Excel format, what methods they are following? Again, they follow the indexing method, hashing method, B+tree or sequential file organization. So some method they follow to store data. So using that methods, again, we can access easily, randomly, we can access the data easily. Okay. This is the concept of the data dictionary. So again, he gave an introduction part I given here. So see here, so data dictionary means it is a dictionary about the data that we store in the database. So we can store data in the database. It contains all the information about the data objects, means attributes. It is like storing all up to date information, means you started the company from 2020. Now today is 2022. Okay. This is June 11th. So up to date, whatever the information you stored about data objects, all these data is available in the database. Okay, objects means what? Again, he given like tables, columns, index, constraints, functions. Okay, all these are will be stored in the database. So like one personal information. Okay. Details of a house. What are the attributes they are having? House name, address, and how many people live in the house. who is the eldest, youngest, and responsibilities of the each member in the house, or security details like who is the owner of a table, okay, and who is the employee of in the company. So regarding like that, we can store the data. So given the example table here, see here, this is the user tables. So user tables, what is the table name, table space name, cluster name. So how many tables are there in the data dictionary? Student table, lecturer table, course table, subject table. This is actually database. In the database, again tables will be there, okay. What are tables will be there? Student table, lecturer table, course table. If we can click that student table, in the student table, what are the details are there again? Student number, student name, marks, okay, and course, admission, when he joined, like that, everything will be available. So this is the data dictionary diagram. So for example, it is clear that any data dictionary would contain the definitions of all database objects like the tables. These are the tables. And views means nothing but the copy. The copy of the table is called as the views. Okay. Constraints means primary key, foreign key. Okay. Whatever the key construct you want to be constraints. And clusters. Clusters also like they can be stores data in the form of the clusters. Synonyms means same name, synonym, English, synonyms, antonyms, synonym is similar words are called as the synonym. And like happiness, joy, both are synonyms like that, okay. Sequences, procedures, functions, packages, triggers, these all are stored in the where in the data dictionary. So it stores the information about how much space is allocated for each object and how much space has been used by them. So, and also data dictionary gives the how much memory is available in the database. Okay, how much is already used. This information also given. And database is the name schema. So what is called schema is what again? Design of the data structure. So see here types of data dictionaries. We are having two types of data dictionaries: active data dictionary, passive data dictionary. Okay, so what is the active data dictionary? So any changes to the database object structure via DDL. So DDL means data definition language. So data definition language, what are the commands we are having? Create, update, rename, truncate, drop. These are the DDL commands. Yesterday we have seen. Okay. So using that command, any changes will be there in the data dictionary. That is active dictionary. So, but updating the data dictionary tables for the changes are responsibility of the database in which the data dictionary exists. In the data dictionary created in the same database, then the DBMS software will automatically update the data. So, any mismatch between the actual structure and data dictionary. So, actually, what he's telling means using the DDL commands, so whatever the updates, modification, logical structure of the database, if you want to do, you can do. So it will be gives the all the updates, whatever the modifications, whatever the changes you are doing, it will be updated. It will be gives the that is the now up to date, means up to date. What are the changes you made in the database? It will be shown. That is the active data dictionary. So what about the passive data dictionary? In some of the databases, data dictionary is created separately from the current database as entirely new database to store only one data dictionary information. So what he's telling here, so actual database is separate. Currently, how many employees are there? And before, how many employees will be there? And before, how many products they will be used? So they maintain separate database. And currently, how many people are there? Currently, they maintain the other database. So here they are not maintained. They are maintained separate databases here actually. Okay. Then, so sometimes it is stored as XML. So XML means what? Extension markup language. Means to create the web page, we are using the HTML language, JavaScript, XML. So XML can be stores the web page information. A web page information is web page database. Okay, what are the commands, what are the data they used, they can be stored using the XML. Okay, and what he given, so stored XML, Excel or any other file format. In such case, an effort is required to keep data dictionary in synchronization with the database objects. This kind of data is called as a passive data dictionary. In this case, there is a chance of mismatch with the database objects, and so already I said. So in the previously active in the what he's telling means it will be maintained completely one database. So from starting onwards up to date, whatever changes will be there, it will be shown. Okay. So like if you are seeing your Google Pay transaction, so from starting onwards, so how many history transaction will be there, that will be shows all transactions. Okay. But in the passive, what happened here? So if you want to take the like example, means previously whatever the business they were doing, that database they separately maintained, but current situation, now present situation, how many members are working, what products they are using, they are maintained separately. So if we can compare the previous and this one, there is a mismatch will be occurred. Okay, mismatch which will, that is called as a passive data dictionary. Okay, and now see structure of data dictionary. So how the data will be stored in the data dictionary. So already we have seen this is the way to store, and again he given like in the system what will be there here, base tables, and again one system what is user views. So users means whatever the users want to be access, that is the front end. And base tables means internally the actual tables will be the base. Okay, the internal tables will be stored in the one system, and the user purpose, whatever they want to be accessed, means the design they don't know, users can't know design. Means like results, if you want to result, or you are searching about any project work, any record, any question bank, so that only you can see. But who's updated, when they updated, and what are the softwares they used, and what are the data type they use to store data, you don't know. Just you are seeing the main information, whatever you want, that only you store. Okay, so user views means this will be shows only front end. This is will be back end. So in the back end, this stores the base tables. Okay, this is structure of the data dictionary. So actually base tables will be seen by DBA database administrators will be, they can know everything, but we people don't know how we can change, we can't. And see, timetable will be, exam timetable will come. Okay, just you can see what there, when the timetable will be, Monday onwards you are having exams, that only you know. Okay, but to prepare that, what they used, if they want to changes the timetable, again they want to be, the exams are postponed. Okay, again who can be do he there, the main people. Okay, like the DBA database administration can be gives the permissions to the other users, they can be changes, they can revoke the permissions, they can be grant the permissions. Okay, they can change it, but the user can't do anything. That is what I am trying to tell here. Okay. So short formly we call at DICT also, dictionary we call na, dict also we call as here. So like he given example, select a star from dictionary, if we can given, then all are the, what are the database tables will be the user resource limits, user password limits, user catalog, all catalog, user clusters, all what are the base tables will be, that all are available here in the dictionary. So dictionary displays resource limit to the user, display password limits to the user. And he is telling clearly, so limitedly user how much he want to access, that only it will be shown. Okay, this is the diagram. So based on the accessibility rights, data dictionary provides the views. User is there, all is there, DBA. 3 views are there here. Okay, user how much he wants, and the user DBA, they both are called as the all. And DBA means only DBA only wants to be see what will be internally data will be there. Okay, so 3 levels are there here. The 3 levels, see here, user view. All view means again we are having these, all are coming here. DBA view, DBA can see the all these user views. DBA can see all, how many users are here. Changes, they want to access data, Okay, so see here the user will list only those tables and views which are created by the current user schema. So whatever the information user want to access, that only they can be accessed. It does not list the tables and views of our schemas, not the ones to which it has access. It displays only those objects that are created by it. But all view list tables and views, owner, who is the owner actually here? DBA can be having the all the permissions. Okay, he only created tables. He can be changes the all. Yeah, he can changes to all whatever the operations you want to perform. He can be changes here. So DBA view will have access to all the tables and views of all the users. So he can see about all the user schemas also. He can be used. He can accessible also. Okay, if and but these views will be accessible by one those. So DBA privileges. Users can be see. The DBA can give the privileges. DBA can give the permission. Then only users can be accessed. So already we discussed that. Only he explained again and again, again and again. Okay. So see what are the advantages here. There is lot of advantage of data dictionary here we are having. So main points here, it gives a well structured and clear information about the database. So what are the advantages? So with it will be gives the well structured manner, okay, and also give the clear information. And one can analyze the requirement, any redundancy like duplicate columns, tables, etc. And what he is giving, duplicate data are not given. Again, data dictionary, if we can store data, redundancy is not there. Okay, means redundancy means what? Duplicate data is not there. Since it provides a good documentation on each object, it helps to understand the requirement and design to great extent. So what design you used, what level, what conceptual level, logical level, what you used, it will be gives the all information internally. And it is very helpful for the administrator. Actually, for the data dictionary is helpful for whom actually administrator purpose only. Okay, maximum here, or any new DBA to understand database. So whenever the DBA joined the company, so what design they use to store data? Okay, how many permissions to the users? So everything the DBA wants to know now. So if the data dictionary will be give the complete information to him, since it has all the information about the database. DBA can easily able to track any chaos in the database. So he can say there, okay, means who are accessing data, who are not accessing, anyone hacking our data. Okay, he can able to see that. And since the database is a very huge, and we have lots of tables. It having lots of tables, views, constraints, indexes, etc. It will be difficult for anyone to remember. So generally, what he's telling his means, if we are to maintain the one company, one business, okay. So there is many types of tables will be there, views will be there, constraints will be there, huge amount of data will be there. So if we want to remember, we can't remember. If we are maintaining a data dictionary means when the transactions updated, when they added the rows, when they deleted, when they modified. So everything is available in data dictionary. So data dictionary is very helpful to the actually whom here DBA, helpful to the DBA or owner of the company like that. And disadvantage also there here. What are disadvantages we are having here? Creating a new dictionary is a very big task. It will take years to create one. So if we want to maintain data dictionary is a very big of task, and it can take the many years also. Means from the 10 years onwards, one company is running. Okay. So from 10 years onwards, whoever wants to create data dictionary, they want to know every information. So when they're getting losses, when they're getting benefits, how many products they are produced, okay, and how many orders will be there, how many cans. So every information they have to create means it can take the many years of time also. Okay, that is the biggest task actually. So it should be well designed in advance to take all the advantage of it. Otherwise, it will create problems throughout its life. Means what is telling, if the information is correct and proper way they created, it's okay. If otherwise they created in the data dictionary only, they stores data wrong way, Then what happened? Complete throughout life, it will creates the problems. Okay, the cost of data dictionary will be high. It includes as the initial build and hardware charges as well as cost of maintenance also. And what is telling here, whenever, so already he said it is a big task and also it can take many years to create it. That means so that much of years they have to be pay the salaries for the project work, and also every year they have to maintain. Whenever they prepare, they created data dictionary, they have to maintain continually years by. So maintenance purpose also the cost is very high. These are the disadvantages of the data dictionary. So data dictionary is also important generally. Means I am guessing as a short answer purpose I am guessing. But B plus tree is the long answer only, ma. B plus tree. What PDF you want? Send PDF today class. So next, structure of the storage. We are having one of the method here, index method. Okay. So in DBMS, just like the storage is organized using various methods. Like already we have seen B plus tree, hashing technique, index sequential file, different methods we have seen now already. So we are having one more method, indexing method. So indexing is used to optimize the performance of a database by minimizing the number of disk access required when a query process. So using the index, what is telling, disk access, disk space is minimizing. Okay. Using the indexing, the disk space is minimizing. That is the main concept of the index. The index is a type of data structure. So I already said the data structure, we are having two types of linear data structure, non-linear data structure. Okay, so in the non-linear, one of the method is a indexed data structure. It is used to locate and access the data in a database table quickly. So using the index technique, so by immediately, if you can point out, you are locating, point out means locate, immediately you can get that file, which file you are indexing. So I said the example, indexing, index means what? In every textbook or every record. So 1 to 50 lessons are there, 1 to 10 lessons are there. So in which page, what lesson will be there? So if we know the page number, we can open. So what that the concept is telling. If we know the index, directly we can search that file, search that record easily. So how the index structure will be there here? Index can be created using some database columns like search key, data reference. In the index, what is there? Two columns is there. One is the search key, one is the data. So using the search key, what data reference you want, you can find out. So the first column database is search key that contains a copy of the primary key or candidate key of the table. So in the search key, what are the keys they are using here? Primary key or candidate key also you can use, no problem here. The values of the primary key are stored in the sorted order so that the corresponding data can be accessed easily. So generally primary key means unique data. Uniquely 1 to 10 files are there. So 1 to 10 numbers will be in the first column. Search key column will be there. So it's using the search key column, we are accessing whatever we need easily. We can access the using the search key. Okay. And second column, what is the database reference? Okay. So it contains set of pointers holding the address of the disk block where the value of particular key can be found. So data reference giving what here actually address of the block ma. Here search key is the indexing. It is giving the address of block. So which address block we store the records, it will be gives the address reference it will be giving. So indexing, we are having different types of methods, ordered indices, primary index. In the primary index, again, we are having two types, sparse index, dense index. So first of all, see here, ordered indices. The indices are usually sorted to make searching faster. So generally, every technique, every method, why they are invented means data will be accessed very fastly, fast access purpose only. Many techniques are developed. So the indices which are sorted are known as ordered indices. In the name only he given here. Ordered indices means what? Whatever the index will be named, that is in ordered wise, in the sequential ordered wise. So suppose we have an employee table. For example, we have employee table with thousands of records, and each of which is 10 bytes long. Okay, so means we have thousands of records. So each record will contain the 10 bytes long. If their IDs start with 1, 2, 3, and so on, and we have to search employee with ID 543. So 1000 records, in the 1000 records, which file we want here? 543. That record we want. So in the case of a database with no index, we have to search the disk block from starting till it reaches 554. So what is telling? If the index is not there in the disk, so what we have to do, all disk blocks begin from starting onwards, we have to search. Whenever the 543 will be reaches, then that file will be displayed. Okay, if we are having the index here, then what happened? So directly you can go the 543. So using that you can take the data, 543 data. Okay. So the DBMS will read the record after reading 543 into 10 equal to 5430 bytes. So what is telling? Data will be bytes, 10 bytes long. So 10 bytes means again he's calculated 543 into 10. So that means 500 for that much of the bytes of data we have to be searched. That is a very long process. So in the case of without index is telling actually without index this much of data we have to. So in the case of index we will search using indexes and the DBMS will the record after reading 542 into 2. Then so 500 so second 542 after the 543 record we need now. So that's why he is taken here 542 into 2 equal to 1084 bytes. So which are very less compared to the previous case. But there is a 5000s of the data it can be takes here. There is hundreds of data. That is the order indices. So see next type we are having primary index. So what is the primary index? If the index is created on the basis of primary key of the table, then it is also known as the primary indexing. So indexing is completely based on the primary key, then that is called as a primary key indexing. These primary keys are unique to each record and contain 1:1 relation between the records. So generally we know primary key means what? Unique data only we can access, and what he given 1:1 equal ratio. 1:1 relation they are maintained. As primary keys stored in sorted order. So generally primary key means 1 to 10, 1 to 100, 1 to 1000 like that only. So the performance of searching operation is quite efficient. So again the primary index is classified two types. So dense index, sparse index. So if you can observe all the methods, all the techniques, maximum nearest same method they followed. Some differences are there here. So indexing methods, order. So 4 types of methods we are having. Order indices, primary index, clustering index, secondary index. So in that order indices we have seen, primary index we are seeing. So in the primary index again he given dense index, sparse index. So what is the dense index here? See here. The dense index contains an index record for every search key value. So he's telling 1:1. Okay. So 1:1 purposely here. So every search key value in the data file. So see the diagram. Whatever the search key will be there here in the table, UP, USA, Nepal, UK. Separately, they are maintained the UP, USA, Nepal, UK. So they are maintained the 1:1. So in this number of records in the index table is the same as the number of records in the main table. So what are the number of records available in the main table? That number of records equally we can store here separately. So needs more space to store index record itself. So here separately how much records you are having, 1000 records. So for 1000 records of data you have to maintain here separately here in this example in this dense index. Okay. So that the index records have the search key and a pointer to the actual record on the disk. Okay. So it can takes the more space actually. Okay. Now see the drawback. If we are telling drawbacks means separately we have to maintain the here search key pointer for the how many records available in this. Here we have to maintain that much of the records here. Now see sparse index. What is the sparse index? It is the method when the size of the table grows, the size of mapping also grows. So automatically, if the size 1 to 1000, 2000, the size of table will be grow means the mapping is also growing. The mappings are usually kept in the primary key so that address fetch should be faster. So there also in the sparse also they are maintained the primary key only again. To mapping the records again primary key only using. Then the secondary memory searches the actual data based on the address got from mapping. So in the secondary storage means wherever the record stored in the secondary storage means what generally they can store data in the magnetic tapes generally, okay, or optical storage in this generation, okay. So using the mapping, in the mapping again they are using the primary key help. So what are the information stored in the secondary memory, they can be given the relation. Mapping means what? Mapping, pointing out. So if the mapping size grows, then the fetching the address itself becomes slower. Automatically increasing of the files are more and more, then what happened here? The mapping is also growing. So in this case, the sparse index will not be efficient to overcome this problem. So it's a sparse index also not efficient, dense index also not efficient. When this problem is if the files will be growing, that time, okay. Now see what is a clustering index. A cluster index can be defined as an ordered data file. So generally any data you can observe, okay, all will be stored maximum ordered only except heap file. Heap file only store the data in the unordered format, okay. There is no ordered. However, where is the empty space is available, the file can be stored there. But the maximum remaining all the files will be stored in the ordered only. All the methods will be stored in the ordered only, okay. So sometimes the index is created on non-primary key columns, which may not be unique for each record. So in the clustering, what is telling, they are not taking the primary key. Up to primary key means what? So if the numbers will be orderly there, then we can give the primary key. So in the non-primary key means what? If the numbers are not ordered, so that is a non-primary key. In this case, to identify the record faster, we will group 2 or more columns to get the unique values and create index out of them. So actually cluster means combining the 2 records, combine the 2 blocks, okay. 2 separate blocks will be the 2 separate records will be there. They can combine, so combine together, they can take the unique values. So that one telling, so see here, we will group 2 or more columns to get the unique values and create index out of them. So take the 2 blocks of the memory, then we can create index. So this method is called as a clustered. The records which have similar characteristics are grouped and indexes are created for this group. So example, see, suppose a company contains several employees in each department. Suppose we using a cluster index where all employees who belong to the same department ID are considered within a single cluster. So what is telling he is, so if we can take the employee, so in department wise, maybe 100 employees are there. So that 100 employees information can be grouping together. So that grouping is called as a one cluster. Not like that separate employee having separate details. So not like that he's doing all the employees of the same department ID within a single cluster. And index pointer point the cluster as a whole. Here department ID is a non-unique key. So non-unique key means what? Not a primary key. It is not a primary key. So here's your department ID and pointer taken. So records 1, 2, 3, 4 records taken. Okay, like this he is pointing out in here, okay. So the previous schema is little confusing because one disk block is shared by records which belong to different cluster. If we use separate disk block for separate clusters, then it is called better technique. So in this he is telling it is a confusion technique. Now see the better technique. What is the better technique he is taking? So in this 1, 1, 2, 2, 2, 3, 4, 4, 5, here you can observe One is only. So same department ID, all the department ID number who's having the same department ID here. And again here. Okay. And again here. Then again here. So like this. So same departments can be making in the same record. Then we can leave 1 means 1, 2 means 2, 3 means 3, 4 means 4, 5 means 5. Like this, we can store in the cluster index. This is a cluster index. And one more index we are having, secondary index. So in secondary indexing, to reduce the size of mapping. So reducing size of mapping, we can use the secondary index. So another level of indexing is in the, so in this method, the huge range of the columns is selected initially so that the mapping size of the first level becomes small. Then each range is further divided smaller ranges. So what he's telling, first take the main mapping size. So again, the first level wise is dividing actually level wise. So first level is stored in the primary memory. So that the address fetches faster. So see here diagram. So first of all, 100, 200 roll numbers we are having. So in the secondary, this is the primary level index. This is secondary level index. So here 100, 110, 120. So what he's doing here actually, so 100 to 200, one level. 200 to 300, one level. So 300 to upon one level. So roll number. So 100, 101 or 110, 120, 130, whatever the numbers will be there available here. Okay. Then again, what he is doing 200, 210, 20 like that. Then 300, 320, 310 like that. Okay. So in this, again, what he's doing here, dividing. He is dividing. You can observe diagram. So 100 to 110, he's dividing. So 122 means 110 to 120, he's dividing. Okay. And 120 to some 150 like that, he's dividing. Then 200 to 210, he's dividing. Okay. 210 to 220, he's dividing. Then 300 to 320. So he's dividing the, what here, dividing the mappings here, dividing the pointers or records. Then it's very easy. Means all are storing in the different levels. This is the primary level, this is the secondary level. So memory is not, we are using not same memory, different memories is taken. Okay. So for example, if you want to find the record of 111, then it will search the highest entry which is smaller than or equal to 111, the first level index. So first level, if we can go to where we have to go, 100 means to about 200 means below 200. Then again we go to his second level. Again, where is the second level? So 120 to one level. So third, like this, it can be find out. So in the first level, so it will get the 100 at this level only. Then second index level, it can be takes the one level and gets then 110. Now using the address 110, it goes to the data block and starts searching each record till let's say one level. So whatever in the diagram he given, whatever he is doing mapping, that only he explained. Okay. So this is about the secondary indexes. So actually indexes, index, what is an index and what are types of indexes? Primary index, secondary index, clustering index, and one more is there now. 4 we are having. Okay. So again in the primary index we are having sparse index, dense index. So generally sparse and dense index are the important for short or otherwise index. What is index means? You can write this types of indexes means we have to write this concept with diagrams. You can explain diagrams. Actual diagrams are the most important here. Okay. So today what I am telling here means you can revise all the units now. So in any unit you are having any topic doubts will be there. Tomorrow you can ask. Okay. Hello.
Yes, ma'am. Okay.
So check the syllabus because tomorrow is the last class now. So any doubts will be there, whatever will be there, you can once tomorrow you can ask. So remaining if any topics will be left from my side, any important topics will be left, that I will see and I will explain tomorrow's class.
Okay.
And you can prepare for any doubts will be there for your side. You can ask tomorrow. Okay.
Okay. Okay. Ma'am, ये important questions पे दे सकते हैं ma'am.
Yes, ma.
Important questions.
I will send in the group, ma. I am having group na.
Yes, ma'am.
I will send.
Okay, ma'am. Thank you, ma'am.
Okay, ma. Thank you so much. Okay. Bye, everyone. Take care.
Bye.